Using functions to model relationships, worksheet 15, questions 14 through 17. Does this problem look familiar? It should look like example 6 of the notes. As a matter of fact, everything is the same except for, I believe in the notes it says Lacey and this is Lainey, and then these numbers here in the Y column are different. Other than that, the questions are exactly the same. So not only can you listen to this video, but you could also use the notes and look at example 6 of your notes to know how to answer this problem. Okay, so for 14, it says let me read the problem first, sorry. Lainey is hiking down into a canyon. The table shows her elevation above the canyon floor at different hours during the course of the hike. So Lainey is starting at the top of the canyon. She starts at the top of the canyon and she's hiking down, so she's descending. Remember that word descending means her slope is going to be negative. So she's descending a certain amount of feet per hour. And then eventually she's going to reach the bottom of the canyon. When she reaches the bottom of the canyon, her elevation will be 0. She'll be on the canyon floor. So for number 14, it's going to ask us to write a linear function that models the situation. In order to write that linear function, that means write an equation, we have to find the slope and the y-intercept. So we're going to use this chart to find the slope. So we're going to take the bottom number and subtract the top number. So 3,575 minus 4,550 is negative 975. 2.5 minus 1 is 1.5. Now, there's not a whole lot of space over here, so what we're going to do is above number 14, that's where we'll write the rate of change. So the rate of change, which is our slope, is the negative 975 divided by 1.5. Go ahead, divide those two out. You should have gotten negative 650 feet per hour. So Lacey is descending, this is Lainey. Lainey is descending at a rate of 650 feet per hour. She's going down 650 feet per hour. Okay, the next thing we need to find is the initial value. Now, before we do that, let's write this down here. So your initial value, which is your y-intercept, is the value of y when x is 1, excuse me, minus the slope. The value of y when x is 1 minus the slope. Right there's that information. Here is where x is 1. There's my value of y. So let's put y with 1 in the parentheses. So 4,550 is the value of y when x is 1. We're going to take that number and we're going to subtract our slope. So our initial value, right small, our y-intercept is that 4,550 minus our slope. Now our slope is negative. Be careful there. The slope is negative, so you have to put minus a negative. You can't just put 4,550 minus 650. You have to put minus negative 650. Okay, so that means you're going to end up adding, which doesn't that make sense? Shouldn't the initial value, your starting point, be greater than the 4,550 because it's at the top of the canyon? If you add those two numbers together, you would get 5,200 feet. Okay, so let's go ahead and change this to white. Put 0 here, and we have 5,200 feet. So our initial value is 5,200 feet. So what you're going to want to do right now, using this information right here and this information right there, go ahead and write your equation. Y equals, put your slope in front of x and your y-intercept behind x. I'm not going to write that equation for you. You're going to go ahead and do that yourself. Now do me a favor, after you write that equation down, so remember you're going to have a number here in front of x, and then you're going to have another number here at the end. Okay, do me a favor and take that equation that you wrote for, that you just found for 14, and write that same exact equation down here. Okay, and I'll talk more about that later. Okay, for 15 and 16, I'm not helping you with 15 and 16. I want you to go to your notes, go to example 6 of the notes. So this is example 6. And for 15, look at problem B. It's the exact same thing. For 16, go to example 6 and look at C. It's the exact same answer. So I'm not helping you with 15 and 16. You can go to your notes and find those answers on your own. Oops. All right, question 17. At what time will Lainey reach the bottom of the canyon? Remember, when she reaches the bottom, that means her elevation will be 0. So let's write that down over here. So let's put elevation, which is your y, will equal 0. What that means is you're going to take this equation over here that you wrote down. It's the same equation that you got up there. And you're going to plug the 0 in for y. So you're going to put 0 equals your slope, the x, and then your y-intercept will be at the end. And you're going to solve this equation for x. It's a two-step equation, which we've done over and over again. So you're going to eventually solve for x, and after you solve for x, your final answer will be Lainey will reach the bottom of the canyon in whatever answer you find that many hours. Okay, so that is it for questions 14 through 17. If you have any questions, let me know.